You see them everywhere, but you probably don't think much about them. Towering over the landscape, those massive steel structures, strung together by wires that hum with unseen energy. We're talking, of course, about electric pylons, the unsung heroes of the modern world. They stand guard over our highways, our cities, and our countryside, silently channeling the power that keeps our lights on, our factories running, and our phones charged. But have you ever stopped to wonder how these behemoths are actually built? It's not as simple as slapping some metal together and plugging in an extension cord the size of a Greyhound bus. It's a dirty, dangerous, and surprisingly intricate process, involving a whole lot of engineering know-how, specialized equipment, and good old-fashioned sweat equity. So buckle up, folks, because today, we're going behind the scenes to uncover the fascinating world of electric pylon construction. We're gonna get our hands dirty, literally and figuratively, as we explore the step-by-step process of how these modern marvels rise from the ground up to connect us all to the grid. Before a single piece of steel is hoisted into the air, the real work begins with engineers and surveyors. These folks figure out exactly where these pylons are gonna go, considering everything from the lay of the land to the type of soil. They use GPS, ground-penetrating radar, and other equipment to create detailed maps and analyses. These things are built to last, to withstand everything Mother Nature can throw at them. Hurricanes, earthquakes, ice storms, you name it. And that all starts with a rock-solid foundation. Once the site is chosen, the heavy machinery rolls in, excavators, drilling rigs, concrete mixers, the works. We're talking about digging massive holes, sometimes dozens of feet deep, and filling them with reinforced concrete. They use steel rebar, thick as your arm, all woven together like a giant metal basket, to give that concrete extra strength and flexibility. It's like building the skeleton of a giant underground mushroom, anchoring the whole pylon to the earth. The exact size and depth of these foundations depend on the size of the pylon and the type of soil. Some soils are naturally more stable than others, some require more reinforcement. It's hot, sweaty, back-breaking work, but somebody's gotta do it. Next time you see one of those towering pylons, appreciate the incredible engineering and hard work that went into building it. With the foundation set, it's time to start piecing together the steel puzzle that will become the towering pylon itself. We're talking massive steel beams, some weighing several tons each, all carefully engineered and fabricated to precise specifications. Think of it like a giant three-dimensional jigsaw puzzle, only with a lot more welding and a whole lot more at stake if you mix up the pieces. There are two main ways to assemble these steel giants, on the ground or in the air. The on-the-ground method is exactly what it sounds like. The entire steel framework is assembled horizontally, section by section, using cranes and other heavy equipment to lift and position the pieces. It's a well-choreographed dance of machinery and manpower, with riggers, welders, and ironworkers all working in sync. This method is often preferred for pylons in open areas where there's plenty of space to maneuver. But what about those pylons you see perched precariously on steep hillsides or spanning across rivers and canyons? That's where the in-the-air method comes in. Instead of assembling the entire structure on the ground, it's built piece by piece, starting from the foundation and working upwards. Imagine a team of iron workers hundreds of feet in the air bolting together steel beams as thick as tree trunks. They use specialized cranes to hoist the steel sections into place. As each new section is added, the pylon slowly but surely rises from the landscape, a testament to human ingenuity and the relentless pursuit of progress. With the steel skeleton of our pylon standing tall, it's time to move on to the really electrifying part, installing the insulators and power lines. These are high-voltage transmission lines, carrying thousands of volts of electricity. Safety is paramount in this stage. The first step is to install the insulators, which act as a barrier between the high-voltage lines and the steel pylon itself. These insulators are attached to the pylon arms using specialized clamps and hardware. Each insulator is carefully inspected for any cracks or defects. Once the insulators are in place, it's time to string the power lines themselves. These cables are thick, heavy, and surprisingly flexible, consisting of multiple strands of aluminum or copper wire. One common method involves using a drone or a helicopter to fly a lightweight pilot line across the gap between pylons. This pilot line is then attached to the heavier power cables, which are slowly and carefully pulled across using a system of winches and pulleys. It's a delicate operation, requiring precise control and coordination. As the power lines are strung from pylon to pylon, they're carefully tensioned to prevent excessive sagging and to ensure that they maintain a safe distance from the ground and any obstacles. With the power lines strung and the insulators in place, you might think our pylon is ready to rock and roll, right? Not so fast. Before we flip the switch, there's one crucial step left. Safety checks. Engineers are back with their clipboards and high-tech gadgets to make sure everything is up to code. We're talking about a battery of tests, inspections, and certifications. First up, the structural integrity of the pylon is thoroughly examined. They use specialized equipment to measure stress levels in the steel. The welds get extra scrutiny, often with X-ray or ultrasonic testing. Next, it's time to check the electrical components. The insulators are inspected again with high-voltage testers. The power lines are tested for continuity. The grounding system is meticulously checked and double-checked. Once the engineers give the thumbs up, it's time for the moment of truth, powering on the pylon for the first time. It's a carefully controlled process, often done remotely from a substation miles away. Assuming everything goes smoothly, the pylon hums to life, sending thousands of volts of electricity surging through those newly installed lines. So there you have it, folks. The next time you flick on a light switch, charge your phone or crank up the AC, take a moment to think about those silent giants standing watch, day and night, rain or shine, silently channeling the power that makes it all possible. It's a dirty job building and maintaining those electric pylons, but it's an essential one. And to all the engineers, ironworkers, linemen, and countless other unsung heroes who make it happen, we salute you. You're the ones who keep our world running, literally, and we're grateful for your hard work and dedication. Now, if you enjoyed this little glimpse into the world of electric pylon construction, give this video a thumbs up, share it with your friends, and let me know in the comments what other amazing feats of engineering you'd like to see us tackle next. Until then, stay curious, stay safe, and remember, it's all connected.